Hi there! In today's video, I'm continuing on my journey to learn the C programming language, and I am going to implement a word counter. So I would like to create a program that takes some text and then counts the number of occurrences of each word in that text. So this might be used in some sort of tag cloud or some search engine to see what are the most repeated words in some file. So let's try and do this. So I will create a new file here called wordcount.c, and here we will have an int main and we will return 0. And what do we have to do? We will have to have some text. So let's make a char text and let's just put some text here now. This is a very simple text example of some text example. Very. So we have some duplicated words there, so we should find those duplicates. So what are we going to do first? First, we are going to use the strtoc function to tokenize or split this by the space. Split the text by space. So we'll take the text and we will put here a space. And we will of course have to set this to a variable. So we'll say char star word equals this. And then we will say while word is not null, we will do the following. We will call strtoc again with null and a space so that it will continue tokenizing the same text. So now word should be the word. Now how do we calculate the occurrences? Well, first of all, null is not defined, so I have to include something, probably string.h. Okay. So if this was PHP, I would just create some sort of variable, an associative array that would be the word count, and then it would have like the word here and then the number, how many times it occurs. But in C, we don't have associative arrays, I don't think. But what we can do is we can have two arrays. So we can have one array for each of the words, for the unique words, so an index of words, and then another array for the number of occurrences of each word, where the index is the same as in the word index. So we can have char word index, which will be an array, and we should have some sort of limit here. So let's say word limit max words, and we will define it here. Define max words will be 1024. And then we will have an array of integers, word count, and again we will use max words as the maximum amount of elements. And then what we can do is we can say that word index wc, let's have this as an iterator here, int wc is 0. So word index wc equals word. And this probably has to be a pointer. I'm not quite sure yet how these things work. So it's going to be an array of pointers, I guess. And this is a pointer. We are pointing to the word that is inside this text. So we are not actually allocating any memory except for inside this value. We're just pointing, it is here, this or is or very, and so on. But now of course we can't do this because then we will add every word here into that index, but we only want the unique words. So we should check if the word is in the index already, then we don't add it. Then we add the count. So in fact, we should have a word count wc equals 1 here. And we should check if word in index. Now this is not a built-in function, I have to create this. So let's put here the word index and the word. If it is in the index, I should in fact say that index is that. I have to get the index of the word from this function. So I will call this above. So we will say int index is that. And then if index is not -1, let's say. So we will return -1 if it's not found. Then we will do all of this. So we will move these up here. Okay. And otherwise, we will say word count wc ++. And here we have to say wc ++. So we increment the index. And then here has to be a semicolon. And then let's create that function here. So it will be an int word in index. And we will take a char star word index and a char star word. And we have to loop through the index. So how do we do that? We can do something like for int I equals 0, I less than max words, I plus plus. And then I guess we should check if we are in the end of the list. So if the word index I is a null character. Is it going to be null? I'm not quite sure. Let's see. Then we will just break from this and then we will return -1. Otherwise, we will say if strcmp, we will compare word index I, to the word. And I think it returns 0 if they are the same. If they are the same, then we return the I, which is the index. So this should return the index of that word in the word index. So then we get the index, and if it's -1, then we add the new word to the index and we set its count to 1. Otherwise, we add to the count of that word. Great. And then we can print out everything that is inside this index. So we can say for int I is 0, I less than max words, I plus plus. And then we can again check that if word index I is a null character, then we will break because that is the end of the list. Otherwise, we will print f, and let's add here string occurs d times and a new line. And then we will pass in the word. So the word will be word index I, and the times will be word count I. So in fact, I think this should work. So let's see if this works. So let's gcc o word count.c. And we got a bunch of errors. So first of all, we have to include stdio because we use printf. And then word in index. Passing argument 1 of strcmp makes pointer from integer without cast. So perhaps I have to add a pointer here, or not. I always struggle with these pointers. Makes pointer from integer without cast. What does that mean? This has to be an array. Okay, that solved it. But then we cannot check if it is a null character. So can we use just null? We can. We don't get an error from that. Initialization of char from char star. This in fact has to be an array. Sorry, it's this way. Text. So let's compile this one more time. And we have to change the check here as well. So if it is not null, then we can compile it. And now it compiles. So let's actually run it. Segmentation fault. Okay, what did we do wrong? Let's add some sort of printf hello, and let's compile it and let's run it. We get hello for each of the words, I think, and actually okay, we get a bunch of hellos, too many hellos. strtalk text, strtalk null. Let's print actually the word here and see what happened. This. So we are not moving to the next word. Why is that? strtalk. I have to set it to word equals strtalk. And then let's compile it and let's run it. And we got some words here. This is a very simple text example of some text example very. So we are printing the words and we are looping through all of the words. But we are not printing the words. So I guess we are breaking every time. Word index I is null every time. So let's print here the word. When we find a new word, we will print it. We never find a new word. So this is always -1 because it should be, if it is -1, then we add the word. So let's compile this and run it. And look at this. We have some output, but it is not correct. This is a very simple text example of some. Okay, so we did get the unique words here. These are only the unique words. And these are only the unique words, but it didn't count it properly. Now, I've had this problem before that this plus plus doesn't necessarily work. So let's see if we can set this equal to that plus 1. Does this do anything differently? Compile and run. No, it does exactly the same. The reason is that I am adding to the word count every time. I should add it only here. When we get a new word, we add the word. And I can convert this back to plus plus. And let's compile this and let's run it. And it does not work. Let's go back to this version. And it doesn't work. So what is going on here? What is going on here is that we have to put -1 here because after we add a word, we are adding to the WC. So it will point already to the next one, but we want to point here to the previous one. Sorry, we do not point to that one. We point to the index, whatever the index is of the word that we are reading from the index. This is what we have to do. So let's compile this and let's run it. Okay, and it actually works. So this occurs 1 times, is occurs 1 times, and very occurs 3 times. Okay, so we can remove this printf here, and let's compile it and run it, and now we only get this. So now it works. We get all the occurrences of the strings. Now, I guess it would be nice if it didn't say 1 times, so we could fix that here. We could have this s as its own thing, and let's call it s, and let's set here char s equals, and it will be word index I, word count I is 1, then it will be nothing, and otherwise it will be s. And compile, and we get an error, and this probably had to be a star. And compile it and run it. So now it's 1 time and 3 times. Okay, that's great. Now, it would be cool if we could sort these results. Now, sorting is something that I have never done because I've only programmed in PHP, and PHP you just say sort, and that's it. You don't have to know how to sort, you just sort. Now, I did do a sort function before when I was practicing for this video, so I do know how to do it, if I remember it. So let's do it. Now, first what I would like to do is I would like to convert this to use structs, because I want to learn how to use structs. So here's what I'm thinking. I will define here a struct. So type def struct, and this will be a word list, okay? And what does the word list have? The word list has an array of words. So it will be actually a word, words, and we will have here the max words, okay? And then I will define another type def struct, and this will be a word. And what is a word? Well, a word has a char star word, so a pointer to a word, and it has an int count, so how many times it occurs. So now what we can do is we can do something like this. We will convert this to use the word list. So this is not going to be a char, it will be a word list, and then we get the word. So how do we loop through the elements of a struct? Well, a struct is kind of like an object in PHP or other languages, but it doesn't have methods or anything like that. So it's just a structure. That tells everything. So what we can do here is we can, instead of using word index like this, actually I would call it word list, because I got this word. But we don't get it this way. We get it by word list arrow words index I. And this will be actually not an array anymore. This is just the word list. And then we get the word list words index I, and here again words index I. So that should work if I'm not completely mistaken. And then let's go back here. And now instead of doing this, we will say that word list equals, and now we have to use malloc, and we have to say size of word list. So we allocate some memory for this word list, which will be the size of a word list, which will be whatever the size of this array is. So it will know that this struct has a maximum words of 124, and they are words, and words have a count and a word. So it will automatically allocate enough space in memory so that we can fit everything in there. And I have to include something, include std_lib probably to get malloc or not. This might have to be a pointer. Okay, now it's happy. So we can remove this one. And we can probably remove this one as well. And then what we will do is we will call this first of all word list. And then what we will do is we will say word list words index wc equals word. And word list words, sorry, I have to say word list words index, that one, dot word. Sorry, this is going to be count. And then this is going to be dot word. So we will set the word list words index wc word to the word and count to the count. And here we will add to the count. And then here we will check if it is null, then we break, otherwise we get the count, and here we have to get word. So let's see if that works. So if we now compile it, we get a bunch of errors. So first of all, we have to move this definition up here because there is no hoisting in C. And now we get some more errors. Invalid operands to binary equal. So perhaps I can say word list words word. But why is this squiggly? Okay, it went away now. So I have to check the actual word, if the word is null. And here, word. Okay, so we have to reference the actual word element in the struct. Property, what do you call it? I'm not sure. What is it called in C? So let's compile this, and it compiles. Let's see if it actually works. Yes, it still works, but now we are using structs. And now that we are using structs, now what we can do is we can sort this struct. So let's create a bubble sort for structs, because that's the only sort that I know how to do. So we will do this. Void sort word list, and we will give it the word list. And then what we will do is we will loop through all of the elements in the word list. So again, we will do for int I equals 0, I less than word max words, I++. And then for every word, we have to loop through each of the words again. So we will say for int j is 0, j less than, and now what we can do is we can say, actually I will pass in here the number of items in the word list. So I will say int wc, and I will replace this with that, wc. So while this is smaller than wc minus I minus 1. So minus I, because once we loop through the elements of the array once, we have moved the smallest element to the end, which we will do now. So we will say here, if word list words index j is smaller than word list, and I have to say the count, if the count is smaller than word list words indexed j plus 1. Now this is why we add -1 here, because we want to check the next element. But if we don't have -1, then we are going to try and check an invalid element. So we'll use count here as well. So if the current count is smaller than the next count, then we are going to flip them in the array. So we are going to say word temp equals word list words index j, and then we will say word list words index j will be assigned to word list words index j plus 1, and then word list words j plus 1 will be assigned to the temp, the temporary value. So now we are flipping them. I think I did this properly. I'm not quite sure. Now, this is of course not a very good sorting algorithm. So if you want to sort like a bunch of data, then you might want to figure out a better way to do this. But let's see if this actually works. So this should just sort it in place. So we can just call this here before we loop through the elements. So we can say sort word list, and we give it the word list and the wc. Now I guess we could have the WC here too, and we don't have to have this break. Perhaps that's better. And I guess we could pass it in here too. I don't know again which one is better. I mean, this gonna work without that, but let's do this first. WC. So let's see if this will actually work. It compiled, and let's run it. And we made a mistake because we are running forever. Why are we running forever? Let's see. I forgot to put J++. So let's compile it and let's run it. And look at this. We actually sorted the array. So we have 3 times, 2 times, 1 time. And if we want to have the least occurrences at the top, we just flip this around and then we compile and we run it, and it should be the other way. Yes, that's great. Now there is an optimization we can do. I will flip this around again, because we don't actually have to necessarily do it this many times. We can set here an integer flipped, which will be 0. And here we can set, if we flip the words, we will say flipped is 1. And then after we have checked all of the possible flips, we will say if flipped is still 0, then we just break, because there's nothing more to do after that. Because this word list might be already sorted from the beginning. So if we run through all of them and the first element is not smaller than any of the other elements, then there's nothing to do. Wait a minute, did I put this in the right place now? Let's see. It's something like this. Compile and run. 3, 2, 1, 1, 1, 1, 1. Okay, so let's actually see if we put here, let's add here int iterations is 0, and let's say iterations ++, and then we will in the end printf iterations, which will be a number and a new line, and we say iterations. So if we don't add this break here and we run this, compile and run, we did 36 iterations. If we add the break here and we compile it and we run it again, we still made 36 iterations, because I have to say equal. Compile and run. Okay, we made 30 iterations now. So 6 less, but it's still sorted. So if we remove this and we compile it and we run it, then we did 36 iterations. So we saved 6 iterations by doing this. Now I think it's going to be more pronounced if we do something like 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 4, 1, 2, 3, 1, 2, and 1. This is our text now, and it is already sorted by the number. So if we now run this, compile and run, 6 occurs 6 times, 5 occurs 5 times, and we have 5 iterations. If we don't have this break here and we run this, then we get 15 iterations. So that's a lot more. So it's good to have this in here. So let's go back to our original text. Okay, so I'm pretty proud of this thing that I have created here. Now, what could we make next? Let's move these iterations from here. I don't need this anymore. Let's actually make this so that we can pass in a file and then it will list all of the words in that file. So how do we do that? We have to read a file to a variable. So it is something like this. File star file equals argv1. How do I fopen argv1, and of course we have to pass it in here. So char star arg, is argc first or argv first? Argc, and this is not char star, this is an integer. Is a pointer or not? I think it is. And then we will have char star argv, which is an array. So now we can get that, and we can say if argc is less than 2, the number of arguments, and the first one is the file name, then we will printf usage s input file, and we will pass in the argv0, which is the name of this, and return 1. Okay, and then we open this in read mode, and then we have to read it. So how do we read it? We call f read, which will take Like, what is there some kind of extension for VS Code that will give me better documentation than this? What is this? Pointer size and size. Reads chunks of generic data from stream. Pointer size file. Let's open CF read. Pointer. This is the pointer to a block of memory with the minimum size. Okay. This is the size in bytes of each element to be read. This is the number of elements. What? I don't even get this. Can I use fgets? It gets a line. I want to get all of fread, come on. PTR. Pointer to a block of memory with a maximum size of size times nmemb. The total number of elements successfully read. Fread. So this is the buffer where we are going to read to. And this is how many bytes we're going to read. And what the hell is one? Nmemb. Number of elements, each one size bytes. What? This is the size in bytes of each element to be read. So this is going to be size of char, nmemb. This is the number of elements, each one with size of. Okay, so char, I have to say char star text. This is where we are going to read to. So we do that. And we read to text size of char. That is the size of the things that we are going to read. We are reading characters. And we are going to read, is this a limit of how much we're going to read? So this can be max string length, max text length. And this will be the file. And then I will define here, define max text length is 20,000. Not sure if we need that much, but let's do it like this. Max text length. Expected an expression. Sorry, there's no equal sign and no semicolon here. Okay, read to text, size of character, this many times from this file. Is that how it works? Maybe. And then we can call fclose file. Let's see if this actually works. So let's make some text.txt. Say here, hello, who are you? I don't know. And let's then run gcc comparison between pointer and integer. So it's just int. And then we will run this and it should tell us the usage. So if we say word count, usage word count input file. So we will give it text.txt. Segmentation fault. Okay, let's look at this closer. fread buffer, char buffer. I have to do this. I have to set the size here. So this is text and the length is max text length. So now if we compile this and we run it, it works, but it is not case insensitive. So if we do this, then it's going to work as expected. Okay, so now it works. Now we can read from a file and count the number of words, the number of occurrences of each word in a file. And we will sort it from highest to lowest. Let's take some Wikipedia article. Wikipedia artificial intelligence. And let's copy some text here. Just Control A, copy everything and paste it in this file. And let's see how my code performs with this. It's probably too long, but it shouldn't matter because we're only reading assertion. What if I just add some numbers here? Okay, now it works. So let's pipe this to less, then we can actually see. Okay, the is 620 times, and of to in from. AI occurs 150 times. Is original tat. Archived, retrieved, Norvig, intelligence 74 times. Artificial occurs 69 times. Okay, so we are actually counting the number of occurrences of each word in the text. That is great. Now, if you would like to use this in some search engine or something, you should probably have it case insensitive and then like remove all the special characters and stuff. And perhaps I will continue this project to make this like a search engine so that I can search through some files and maybe find the best match for a given search term. That would be cool. to make that in C. But this is going to be the end of today's video. I hope you enjoyed it. And as always, you can find this on my GitHub page if you want to check it out and try it yourself or make it better or something. So I hope you enjoyed today's video, and make sure to subscribe if you want to see more videos like this in the future. Thanks for watching, and I will see you in the next one.